Okay, we're back. So I was going through this list of different sorts of ideas. Um, I have no shortage of ideas for thesis work. People who have done thesis with me have done a whole bunch of different sorts of theses. Every student has their own idea. Every student has their own what I will call educational identity. And that is part of what the thesis is about. It's about exploring your own area of interest. And everybody has their own area of interest, their own ideas which they will champion and make their own. And so I think it's very good if you put on your thinking cap and come up with your own notions, your own creative ideas. Let me see if I can use this tool here. Here's my pen. It's not drawing. Oh, there it is. So there are these things which we call transforms, which are important for signal processing, and different transforms have different reasons for their being used. I was exploring this idea of using integer Haar transforms because I'm very fond of using small microcontrollers. And these small microcontrollers are able to work without any floating point units. And without any floating point capability, you look for very specialized transforms. And so I was very interested in using integer transforms. So I got involved with these sorts of things. I do a lot of image processing, and color quantization is one of the areas that I explore heavily and deeply and write about. And there are also areas where you'd like to maybe look into image coding, perceptual coding. And this is good for image compression, image sequence compression, image sequence segmentation, maybe even image identification, like take a camera, point it at something, tell us what it is. Like, oh, there's $10, so that's a change on the desk. That's computer vision. So there are other things which we've been working on for teaching, and image processing for teaching may mean, in effect, coming up with better I'll call it image sequence coding systems that are good for screen captures. And so I do an awful lot of screen captures. And coming up with efficient screen capture coding techniques is one of those things that might be really good for a thesis. I do work with robotics, because I mentioned my thesis is in autonomous land vehicle robotics. We've got a lot of interesting and wonderful robots here. We've got this theory I have, which is that students love robots, and students like beer. So I have this robot that will bring you a beer, all right, because what could be wrong with that? And so it's called TidyBot, and it's got a gripper, and it will hold the can of beer, and it's got wheels and sonar sensors, and it can take your beer and bring it wherever you need it. Perhaps your easy chair, because one shouldn't actually have to get up to get one's beer. It could be a hardship. We have a wheelchair, which is electric, which is very good for people who want to automate the wheelchair system so that it can respond to individuals who can't control the wheelchair. I have a friend who is a quadriplegic, which means they cannot move their arms and they cannot move their legs. So they cannot control the wheelchair directly with the standard joystick. So it'd be really good if we could come up with a thesis proposal that makes use of that wheelchair and maybe a brain-computer interface or some other interesting computer-human interface for driving the wheelchair around. Because then, it's empowerment. It allows an individual to take control over their own life. So there are these, I'll say, interesting things that happen when you do image processing, but image processing is hard. And a lot of people have trouble programming. And so we have these visual programming languages for doing data flow type processing, and you can use those for our image processing. And it'd be great if we could explore those a bit as part of a thesis. Lots of ideas. I've got this ongoing voice and signal processing course, and if I could get a visual programming language for the voice and signal processing, that would be great too. And I've got a couple of visual programming language prototypes already. Students love games. and I teach a course in 3D games. 3D graphics are used for biomedical visualization. They're used for the 3D gaming. I used to program games for a living for the phone company. And it's one of those things where there's a lot of money in games. People really enjoy playing them, and they like to spend tons of money on them. So there are these companies in this country that make billions of dollars when a new game gets released. And they do it quickly because everybody has to have them. I've got an embedded face recognition project I worked on a bit. What this does is it lets you find the terrorists. You know that when they had the Desert Storm, they would send the soldiers out with a deck of cards, and the deck of cards had the faces of all the known terrorists. And as they were playing cards, they became very familiar with the faces. But if you had a computer that was handheld, you could do portable embedded face recognition. And so you wouldn't necessarily need to use the deck of cards in order to be able to find the terrorists you're looking for. I've got a new textbook that I'm working on. I just came out with a new EPUB book. I'm not sure if you're familiar with EPUBs, but they're essentially sold electronically by Amazon. And Amazon gives you 70% royalty, which is unheard of in the industry. And so that's a big deal. It's taking the industry by storm in terms of getting textbooks out. Let's see now. Radar decluttering, scientific visualization. These are all areas where you could do interesting and wonderful work. One thing that I found is that BYU, Brigham Young University, has a product called JHDL, which is HDL for Java, which is kind of interesting, but I never explored it. I'd love to have somebody explore it as part of part of their thesis work. So I've got all these interesting and wonderful ideas. I always start by asking you, what are your ideas? And then you're quiet. So I say, okay, you don't want to tell me your ideas? Fine, I'll tell you my ideas. And then maybe you'll come up with your own ideas. So you have to get your own ideas. You may need help from me. I'm happy to help. And maybe what we should do is take a little time right now and brainstorm. Brainstorm about areas where you're interested in. So show of hands, who here is more interested in hardware than software? Hardware. No hardware people here? Really? Okay, who here is more interested in software than hardware? Oh no. Okay, and who here is interested in voting? Raise your hand if you'd like to vote. No? Okay, if you don't like to vote, raise your hand. Alrighty then. So what we have here is a bunch of people who don't care about hardware, they don't care about software, and they don't care about democracy because there's no voting. This is terrible. What kind of students are you? You can be proud of yourselves in this way? How do you live with yourselves? This is terrible. So you know that you're in the electrical and computer engineering program. You know this, right? And electrical engineers and computer engineers both can do hardware and both can do software. But you're interested in neither. So what are you interested in? Nothing. Not interested in nothing. I'm going to start calling on people. Oh, okay. Riti. That's you. Yes, you're first because you're at the top of the list. What areas, what courses were you interested in when you were an undergraduate? Which ones were really interesting to you? Power. Great. So if you wanted to do a thesis, would you do a thesis maybe in power? Ah, that's it. Now we're getting somewhere. And power, that feels like hardware, right? Yeah, what kind of power? Like green power? Task machines? Oh, transmission lines. Ah, okay. That's interesting. You know that there's a power company nearby. Did you know about that? Connecticut Light and Power. And they have a lot of their students come to our program. I have a bunch of power students, actually. Some of them did thesis proposal work. One of the things that we're very interested in here in Connecticut is smart grids. So is that of any interest to you? Because smart grids it's both hardware and software. Smart grids, and they use sensors to try and determine how much power is being drawn. And maybe it's good if you are trying to figure out what is it in the house that's drawing so much power. That'd be very good. You could use it as power conservation thing. You could say, that thing is costing you an extra $40 a month because you leave it on all the time. And you say, oh, I didn't know. It's so important. And here in Connecticut, power is very expensive. So it's one of those things where people are always looking for ways to save money. If I see a power bill at the end of the month, I just looked at one, and it was an extra $40. And I said, what is going on here? $40, that means there's something that is consuming 150 watts that's on every day, all day long. How am I getting an extra 150 watts on all day long with this extra $40? I mean, it's ridiculous. There's something on. I don't know what it is. I'd love to know. And Anurup? Did I pronounce your name wrong? Anurup. What areas, when you were an undergraduate, were interesting to you? VLSI design. That's great. So, are you taking advanced digital design? Good, good. So maybe you'll be interested in doing something like these VHDL ideas that I had. Or maybe you've got your own. You have some ideas of your own for VHDL? What are they? What is it? You have to think about it. Okay. CIRAM? Did I say it right? Who is CIRAM? Yeah. Did I say it right? Yes. What areas are interesting to you? And when you were an undergraduate, which courses were interesting?
I'm interested in VLSI.
Also, okay. And do you also have to think about it, or do you have some ideas that you might like to?
Actually, I need some time. I have other ideas also.
Okay.
So,
All right. Well, I can tell you a little bit about the VHDL course. The Altera course, we use Altera, has these boards, and I've been able to use them to run Unix. So you can actually get a full-blown 32-bit RISC machine running a small version of Unix, and it runs X Windows and lets you run Emacs, and you can do all kinds of interesting and wonderful things in the on the Altera boards. They've got all the I/O, the video in, the video out, the what do they call this? USB interfaces. All that stuff is all in there in the boards. So you got a full-blown development system if you want, and you basically can make a system on a chip with the FPGA. So you guys are going to have to think about some problems that you'd like to try and attack. Maybe what we should do now is take out a piece of paper and write down a problem that you've had. Write down why the problem is important, and write down a possible solution to the problem. I'll give you an example. I have a problem. Whenever I call up my bank, it's a pain because I have to dial this other thing, and it says if you want English, you press 1, and for security, put in your account number, and then enter in your PIN, and then if you want this, then hit the other thing, and then if you want that, hit this thing, and then it goes through. They call it voice jail. I hate voice jail. So that's a terrible problem to have, so I wrote a program to get out of this problem. Discard. And I deployed the program using Java Web Start, and I call it the address book. And the address book navigates through the voice jail. right? So this is a basic solution to the problem, right? So if I want a voicemail, it goes through the voice jail and gets you through it, which is really important, I think. I got another thing where it solves problems with data mining, giving you points of interest for your GPS, or data mining for the stock market, where it's doing financial data mining. So little problems that I try to solve, I can encode these problems into a formal language and try and get that language to do the solution for me, to help me automate my way through the problem. So it's a great way to deploy the problem and deploy the solution to the problem. And it's one of those things where people are always interested, I would say, in coming up with semi-automatic means of solving problems. Here's a problem I was solving for one client. We wanted to be able to design diffraction rangefinders. So we designed our own diffraction range finding system. This little red part over in here is the laser. This here is the camera down in here, and in principle you should be able to move just the laser or just the camera and see how the rays intersect with the little grating off on the corner. So here's the camera. I should be able to steer the camera around a little bit. And here's the laser. I should be able to get the laser to intersect with the rays of the camera. And then here's the grating, and I should be able to move the grating around a little bit. And I could probably drag and drop the whole thing. And now we should be able to see range as a function of distance. Well, let's see. Range is a function of deflection across the back of the array plane in the camera. And I don't know if you can see that. It went off the screen. Well, that's okay. The goal, of course, is not to get you the solution, but to show you that there are interesting and wonderful ways that you can create solutions to good problems. Get out of this thing. I had a problem where I wanted to be able to deploy speech synthesis automatically using Java, and I thought that it would be a lot of fun to be able to deploy that using Java WebStart. And so what I ended up doing was writing a Java speech application that lets you sort of say ECE 420 is cool.
S420 is cool.
Yeah, sort of works. Sort of. Not the best, but there it is. So if you can find an interesting problem and you want to automate your way through it, write some program about it, that's a great way to go for a thesis, or at least a thesis proposal. I've got a bunch of these things, so I won't drag you through them. But there it is. Let's see what else we got. I guess that's what I have here for today, my intro lecture. So you guys, did you take out a sheet of paper and write down some problems? Problems that are of interest to you? I think you should do that now. Write down a few problems. Want to take a little time and do that? I'll pause the video while you do. Intellectual property is an interesting concept. Does anybody know what intellectual property is? No? Well, if I have an idea, and it's my idea, isn't that intellectual property? Yes, absolutely. If I have a fanciful design right? Like Coca-Cola, right? Isn't that intellectual property? Right? You've seen the Coca-Cola thing that's very fanciful. It not only is an interesting name, but they draw it interestingly. Right? That's what they call a trademark. That is a piece of intellectual property. Belongs to the corporate entity. Right? You can have your own trademark as an individual. I have a trademark, Doc Java. It's trademark. There's things that people do when they want to protect their ideas. Anybody know what they are? How do you protect an idea if it's your idea? Yes, you patent the idea. If you can patent the idea, then the idea is something that you can keep others from practicing. And if you can keep others from practicing and they want to practice it, you can license your idea to them. So if you have an idea for wireless charging of phones, but you don't want to build your own business out of it by manufacturing your wireless charger, maybe what you can do is you can license it to others. And then they will pay you a royalty every time they make one of these wireless chargers and sell it. And so they have to pay you, and so then you can sit around and bring in the big bucks. What a wonderful idea. Suppose you had a book and you wanted to lay ownership of the book that you wrote. Well, you could copyright the book. That is a way to protect intellectual property. If you had some code that you wanted to disseminate and you wanted it to be your own code, right, and keep it as yours, you could copyright the code. But if the code has an algorithm and the algorithm represents an idea that is uniquely yours, you could patent the algorithm. You copyright the code, but you patent the algorithm. You don't copyright the algorithm. And you don't patent the code. Right? So it's a sort of an interesting notion. If I have copyrighted code and it's written in Java, I could rip it off by rewriting it in Fortran. That doesn't violate the copyright. So I can take the ideas, reverse engineer the code, and come out with, let's say, VHDL, and implement the code in VHDL. It doesn't violate your copyright. But if you have a patent on the algorithm, then I take your code and rewrite it. I violated your patent because I'm practicing your algorithm without permission. Patents, trademarks, copyrights, these are all ways in which you can protect intellectual property. But there are other ways too. What might be another way to protect your intellectual property? You all sat down just now and you wrote down your ideas, right? Someone said, well, I'm going to do something with priority encoders. Someone else said, I'm going to do something with wireless charging. Someone else said, I'm going to do something with power distribution. All of these basic ideas are useless unless you have a way to reduce them to practice. And if no one else knows how you reduced your idea to practice, then what you have is a trade secret. Trade secret is another way in which you can protect your intellectual property. Trade secret is what you use to protect the formula for Coca-Cola. So when you think about Coca-Cola, you might have a trademark, right? Coca-Cola is a trademark. You might have a recipe for Coca-Cola that's closely guarded. Only a few people know the recipe. And that's a trade secret. So keeping trade secrets is a great way to protect your intellectual property. Then you don't have to spend any money at the patent office. You don't have to get a copyright. You don't have to deal with trademarks. You have a trade secret. It's your secret sauce. The best stuff, let's say from the chemical companies, is going to be, well, they patent the process, but the actual ingredients that go into the process, that's a trade secret. The recipe they keep quiet on. And if you don't know exactly how the ingredients are combined or in what order, you won't be able to reproduce the chemical. So in terms of nailing down your intellectual property and keeping it to yourself, there are a few different options available to you: copyrights, patents, trademarks, and trade secrets. And these are the common means of taking intellectual property and holding on to it as though it were your own. So important. In this country, it used to be the case that the patent system was based on the first to invent. So if you had a notebook and you could prove that you invented it first, then you got priority at the patent office. And usually the notebook was written down in a place where you couldn't tear out pages, in a place where you couldn't insert pages, a sewn book. And then you would write read and understood underneath some idea, and you'd present it to somebody for consideration, and they would sign off on it and date it to prove that you had invented it at a specific time. And that's how you established priority. But then what happened back in March of 2013 is the America Invents Act kicked in. This is called patent reform. And now the United States is on what's called a first-to-file system, which is consistent with the rest of the world. And so now if you come to the patent office first with the idea, then it's your patent. And you get the patent, which means it's a race to the patent office, which means you cannot tell people your idea and not worry about it being ripped off in this country. So this is one of those big problems now. So you want to protect yourself when you have these ideas. You want to keep them to yourself, closely held. You want to be able to still discuss them. So what happens in a classroom setting like this is when you disclose your ideas in a public forum, and I upload stuff onto the network, you have to be a little bit careful about disclosing the whole idea. You may want to keep some part of it to yourself, the part that requires a reduction to practice, the part that requires the trade secret, the part that you don't necessarily want to give away. Because if these ideas actually do have value, you want to try and guard them somewhat. So just to say, well, I plan on doing something with the power grid, that's okay. But if you have very specific details that you don't want to disclose to anyone, then don't talk about it. And that's important. So that's what I've got for you for today. I think we're out of time. You've got a homework assignment. I'd like you to submit it using Blackboard. If you're driving, be very careful. I think this is one of those times when if you have never driven in the snow, this is not a good time to be learning because it's dark and it's slippery. So have a good evening. Thank you.